Hello everyone. Let's solve the questions of previous year based on ray optics. The first question is two thin lenses of focal length plus 40 centimeter and minus 20 centimeter and placed coaxially in contact. An object is placed at infinity in front of the combination, and we have to find out the position of the image here. So what is given here? We are having two lenses, thin lenses, whose focal lengths are given as one is plus 40 centimeter and second is minus 20 centimeter. And when the two lenses they are combined and placed coaxially in combination, the net focal length is 1 over f is equal to 1 over f1 plus 1 over f2. So we are finding the focal length of the combination here. 1 over f is equal to 1 over 40 minus 1 by 20. So here you will calculate the focal length of the combination, as here it would be 1, here it would be minus 2, and you would get minus 1 by 40. So this is 1 over f. So taking the reciprocal, f is equal to minus 40 centimeter. Now you see, initially both of the lenses, one focal length was positive, one was negative. So one was convex, one was concave. But the combination, we have got the focal length as minus 40 centimeter. It means this combination is behaving as a diverging lens. And now the question is, one object is placed at infinity in front of the combination where we are going to expect the image. So here object is placed at infinity, and you see when the object is at infinity, here we are having the two lenses which are in contact, one is convex, one is concave, and we know that when the rays are coming from infinity, then as this combination is behaving as diverging, both the rays they are going to diverge, but they would appear to meet at the focus. So and the focus is minus 40 centimeter. So here you would get the image of the object which is lying at infinity. So here we can choose the option. Which option is correct? Option B, you can see at a distance of 40 centimeter in front of the combination. So here option B would be correct. So here we have to basically find the focal length of the combination. As object is at infinity, image would be at the focus of the combination. Question number 2 is, here question number 2 and 3 are given as. Question number 2, the real image of an object is formed at a distance twice the distance of the object from the concave mirror of focal length 10 centimeter. Here we are having a concave mirror. So focal length 10 centimeter, as it is concave mirror, so it is minus 10 centimeter, and the object is placed at a distance, image of the object is formed at a distance twice the distance of the object from the concave mirror. So here, if this is a concave mirror, let us consider object is lying here, this is u, and we are getting a real image. Real image, we know that it would always be inverted, and this is at a distance of 2u from the mirror, as it is given in the question that the image is formed at a distance twice the distance of the object. Now using this concept we can find, and what we have to find here, find the distance between the object and the image. So this distance we have to find out. So we need to find out the u basically here. This is also u plus u is 2u. So we need to find out u here using the formula. This is concave mirror, so we will use the formula of the mirror. 1 over f is equal to 1 over u plus 1 over v. Now you see, using sign conventions, object distance is minus u and image distance would be minus 2u, because both of them they would be in front of the mirror, so both of them they would be negative. And here focal length is also negative because this is a concave mirror. So this would be 1 over minus 10, 1 over minus u plus 1 over minus 2u. Now let us find out the value of u from this equation only. So this is minus 1 over 10, minus sign I'm taking common, 2u, and here you will get 2 plus 1. Minus is eliminated. So 2u over 3 is equal to 10. U is equal to 10 into 3 by 2. That is 15 centimeter. So this is the distance. U is also the distance between the object and image. So this distance is 15 centimeters. So anything we can calculate. And if you want to find out the distance of the object, this would be 15, and image is at a distance of 30 centimeter from the mirror because it is at a twice the distance of the object. So the distance between object and image is 15 centimeter. So this was question number 2. Now question number 3 is after or. It is an object is placed 1.5 meter in front of a lens of power 4 diopter. Here u is given as 1.5 meter and power of the lens is given as 4 diopter. So positive power, it means this is a convex lens or converging lens. Find the nature, position and image of the image formed. So u here is given. From power we can find out the focal length, and simply we have to use the lens equation to find out the nature, position of the image. Now as it is placed in front of the this lens, so it has to be negative. Power is positive, so we can find out the focal length from the power using this formula. Focal length is reciprocal of power, so this would be 1 by 4 diopter. When the power is in diopter, we would get the focal length in meters, so this would be 0.25 meter, or it is 25 centimeter. And u here is 1.5 meter, means it would become into 100, it would become 150 centimeter. Now let's find out the value of v using lens equation. Lens equation is 1 over f is equal to 1 over v minus 1 by u. Now let us substitute all these values. 1 over f is 25, v we have to find out, u is 150 minus 150, so this minus would become plus, so 1 over v, this would go this side and it would become negative, so it will be 1 by 25 minus 1 by 50. So little simplification, 150, here you would get 6 minus 1, and v would be 150 over 5. So v we have got as 30 centimeter and it is positive, so it means the image is formed on the other side of the lens. So this is the position of the image. It means image is formed at 30 centimeter from the lens on the other side of the lens, the side in which the object is not placed. And other things, position we have found, and we have to find out the nature of the image. So what is the nature of the image? So in order to find out the nature of the image, you can find out the magnification. So magnification, we know that it is v over u. In case of lens, v we have got as plus 30, and u is, what's the value of u? It's minus 150. So what we have got this as 1 over 5. So magnification is minus 1 by 5. So here magnification magnitude is less than 1. So when the magnification is less than 1, it means image is diminished. If it is equal to 1, image and object size, they are same. And if it is greater than 1, it means we have got the magnified image. So less than 1 means image is diminished. And negative sign is showing here the image is inverted image. Image is, and we know that inverted images are always real. So this was our question number 3. Question number 4 is, state the condition under which total internal reflection occurs. So conditions, as this is a theoretical question, we already know 2 conditions are there. One condition is the ray must go from denser to rarer medium, and second condition is angle of incidence must be greater than the critical angle. Only then the total internal reflection would take place, otherwise it will not take place. Second part of the question is, a glass slab 3 centimeter thick is placed over a dark ink dot. Now you see this glass slab is placed over, and its thickness is given as 3 centimeter. It is placed over a dark ink dot. Find the height through which the image of the dot is raised. The refractive index of the glass is 1.5. Now you see, if the dot is lying here, because of the refraction, this dot would appear here at this point. So through what distance this dot has been raised, this we have to find out. So the relation between the real depth here is 3 centimeter, and this is the apparent depth which is appearing to us. So refractive index is real depth over apparent depth. So we can find out apparent depth. So subtracting the two, we can find out the distance through which the dot has been raised. This is 1.5, this is 3 centimeter, and this apparent depth we have to find out here. So apparent depth would be 3 centimeter over 1.5. So 1.52. So apparent depth here is 2 centimeter, means the dot would appear to be at a depth of 2 centimeter. So by how much distance the dot has been raised? The distance through which the dot is raised, that is 3 centimeter minus 2 centimeter, that is 1 centimeter. Now question number 5. In this question, it's given that a ray of light is incident at an angle of incidence a by 2 on face AB of the prism ABC. Now let us draw a prism ABC. And angle of prism here is A. The ray emerges normally from the opposite face. So here the ray is emerging normally from the opposite face. It means if it is emerging normally, it means here also angle of incidence for the face AC has to be 0 degree, or it must be falling normally on this. So let us consider this is A, B and C. here you have to draw the angle of incidence. Now let us consider this is the angle of incidence, which is equal to a by 2. Here this is angle R1 and R2 here is 0. So as we know that R1 plus R2 is A, so R1 plus 0 is A, so R1 has to be equal to A, and here angle outside is A by 2 as per the question. So if you will apply Snell's law here at this point, you will be able to find out the relation between the refractive index and the angle of prism. So if you will apply here you have air, and this is the refractive index of this medium, so we can write refractive index of air sine of a by 2, refractive index of the medium sine of a. So n is equal to sine a by 2 over sine a. So here in this relation you can see a and n are appearing. So if you will simplify this, 2 sine a by 2 cos a by 2, sine a by 2 would get cancelled. So n here is 1 by 2 cos a by 2, or 1 over n is equal to 2 cos a by 2, or cos a by 2 is 1 by 2n. So this can be the relation between n and a as per the given condition. B part of this question is the focal length of the convex lens of refractive index 1.5 is 20 cm. Find the focal length of the thin lens when it is immersed in a liquid of refractive index. So B part of this question is 5b. The refractive index of lens is 1.5 and its focal length in the air is 20 cm. Find the focal length of this lens when it is immersed in a liquid of refractive index 1.5. So medium whose refractive index is 1.25, when the lens is placed in this medium, we have to find the focal length. Now using the formula, 1 over Fa is refractive index of the lens, refractive index of the air minus 1. So this is a lens maker's formula. Similarly, for other medium whose refractive index is given, the focal length will become refractive index of lens, refractive index of the medium minus 1, 1 by R1, 1 by R2. Now taking the ratio of the two, 1 over Fa over 1 over Fm. So this bracket is going to be it's going to be cancelled. So refractive index of air is 1, so I am writing simply mu L minus 1, and here I am writing mu L over mu M minus 1. So this would become Fm over Fa. Mu L is 1.5 minus 1, and here it is 1.5 over 1.25 minus 1. Now the focal length in the air is given as 20 cm. So this is 20. This would become 0.5, 1.5 or minus 1.25. So this would become 0.25 over 1.25. It would go to the numerator. So this will become 0.5 into 125 over 25 into 20. So this would become 2.5 into 20, or Fm would become 50 cm. So the focal length of the lens when it is dipped in some liquid whose refractive index is 1.25, then its focal length will become 50 cm. So that's all for today. Thank you.